Welcome to the Healthcare AI weekly live broadcast with the Health Catalyst Data Science team, where we discuss the latest in machine learning topics with hands-on examples. Here's your host, Levi Thatcher.
Welcome out. This is the machine learning broadcast. Mike Mastanduno. I feel like it's been a while.
Yeah, Levi, we haven't been on this side of the desk together in quite some time.
I've missed it.
What is it, 2 weeks?
It's been a while. I was out last week. Heard things went amazingly while I was gone. Sorry I'm back. I will try to get back in the groove here.
Yeah, it's great to be back. So what are we talking about today?
So open healthcare data sets. So how do you find data to play with? So let's imagine that you're wanting to use our healthcare AI package and the 1,000 rows we give you aren't enough. So how do you go and find more data to play with since healthcare is such a lockdown environment, so many security concerns? We'll dive into that, and I'm excited for it.
Totally. It's going to be awesome. So I guess, we have some bookkeeping to do at the beginning of every show. We want to remind you to log into YouTube so you can chat with us. We want to answer your questions on the air. Feel free to try and engage with us, and if we're not too flustered, we'll definitely try and respond. Make sure to increase your video resolution with the gear in the lower right. We're going to be doing a lot of code work today, so it'll definitely help. Nice to see you, Jonas. Glad to have you back. You're a regular subscriber. The rest of you, please subscribe. Our broadcasts are better by having more people watching them and a better community. And on that note, you can join the Slack channel, community, healthcare.ai, and we can, continue the conversation throughout the week.
Yeah, keep it going throughout the week so that, things don't just drop off, because we want to actually have a discussion back and forth. And so the Slack channel has been great for doing that, and we're excited to build on that progress we've made. Yeah. So what's first today? What are we diving into?
So today we're going to do the mailbag. We missed it last week to talk about an excellent article that was in the New Yorker. Again, if you haven't read it, I hope you will. It's by Siddhartha Mukherjee, who's a Pulitzer Prize-winning author and physician, and he writes a great article about AI in medicine. Again, it's in the New Yorker. Check it out if you haven't.
20 pages long, probably.
Yeah, it's a 20-minute read.
But it's amazing.
Yeah, it's 20-minute read. It was awesome. And so we'll do some questions from users. We've had a few pile up over the course of the week, and then we'll dive right into some healthcare data sets.
Yeah, and we'll do a demo. So live coding. Stay tuned.
We're going to put Levi on the spot and see if he can code under the gun.
Trepidation there. So first question from Paul. Would dynamic machine learning be better than static machine learning in healthcare? So this has come up a lot. Hot topic.
Yep.
Dynamic ML? It seems dynamic as it is. The machine's learning.
Yeah, so what is the difference between, what does Paul mean by dynamic ML?
Yeah, so this is a good one. And what people are wondering is when you have a model that's driving risk stratification, so let's say we're predicting each day who are our most at-risk patients for sepsis, does that model learn each day that it's in production? Is it constantly getting better? Because you feel like, okay, the robots in the movies, they feel like they're learning from their environment, right?
Yeah, for sure.
Yeah, well, what about our sepsis model?
Well, our sepsis model is not learning from its environment because it's built, it's there's a lot of different machine learning algorithms.
Yeah.
Some are dynamic, some are not. So, the sepsis model is built on a random forest, which kind of takes this huge data set and digests it and learns all it can from that data set all at once. And then it's just, applying that knowledge to new rows and new predictions. There's another class of machine learning models that can take feedback from new predictions, and those would be like Bayesian classifiers or recurrent neural nets.
It's a little more like ongoing over time.
Yeah, so they improve over time. But, the good news about the sepsis app is that, sepsis, we're looking back 3 years, and we don't expect sepsis to change a whole lot in the next, month. And if it does, we can retrain our model and get that new input.
That's a great point. So with sepsis and a lot of these clinical use cases, you're predicting on 30, 60,000 rows, and then each week, like for CLABSI, which is central line infection, you're predicting for those folks that have a central line in them, so it's only a few hundred people a week. So your data doesn't turn over from week to week, really. You're able to take advantage of the past data and not really worry too much about necessarily what you're learning that week. You're just trying to predict for those folks that week. So I think that covers a lot of machine learning use cases and a lot of different algorithms.
Yeah. And I guess it would be worth stating that, again, it comes back to your use case. If you have a really high turnover data set, you might get more value out of a dynamic algorithm.
Sometimes called online learning.
Yeah.
I've read that term, so that's something you can Google if you're interested. So great question, Paul. Paul 1.
So second question from Paul 2. Paul 2 said, we have that a barrier for machine learning in healthcare is basically, why should we spend resources on this? We don't even know that it works. Formal studies haven't shown effectiveness. And he just asked us to comment on that. So I'd love to comment on that, Paul, number 2. Thank you. I think, why should we spend resources on this? We don't know it's good. Well, machine learning in health, machine learning is in every aspect of our lives these days, whether you like it or not. Any website you visit, any marketing effort that's directed at you has been done by machine learning. And I would say that the internet is quite a bit better than it was 5 years ago even.
Oh, definitely.
Netflix is a great experience.
Oh,
and
man.
Machine learning makes that possible. So it seems silly to think like, oh, just because it hasn't been validated doesn't mean it can help. It's helped in every other industry.
Yeah, it's like saying, okay, well, why should we use math to do this when we could just guess? I'm not making fun of anybody really, but just so machine learning is math, and so it's like, okay, well, if we're all about data and excited about data, it makes sense to use math to analyze the data. That's kind of the gist.
Although I guess the other side of the coin is that it is healthcare, so this is
it's a special arena.
Yeah, potentially your medical advice. You don't want that to be coming from a machine that's unvalidated. So
yeah,
you
gotta test it.
It can be sticky too, but I think the benefit is gonna show in the years to come.
For sure.
Yeah. If we have anything to say about it.
Exactly. Great question, Paul 2. We'll find out we'll go with Paul's. So question 3 from Francis. Do you provide example code for a lunch and learn type course?
So Francis was...
we need to respond to you, Francis, an email.
Yeah, so Francis sent us an email, and he said he was tasked with giving his organization lunch and learn or a brown bag or kind of like a use R for healthcare data analysis. And do we have any example code? So Francis, I think, we'll respond to you separately in case you missed this, which would be crazy because who would miss this? But we have the example code in healthcare AI. You could do some things with that. And then we also have a few R notebooks that are, I think they're hosted on the blog, that you could use as a starting point for what you're interested in covering.
Reading our blog, never a bad idea, Francis. I should read it more, in fact. So check out healthcare.ai to go to the packages to see those examples that are tied to the documentation. And then on the blog, there are the notebooks, just to repeat everything that Mike said, essentially. Just so I understand everything, like to repeat stuff.
Cool. So great mailbag this week. Please keep the questions coming. We enjoy getting the feedback and thinking about how it helps us learn new things too, which is awesome.
Yeah. Online learning, that was interesting. Okay, so mailbag is good. What's on the docket? Open healthcare data. So open, why do we say open? I guess we could start with.
So open healthcare data, that's actually a pretty small percentage of data, because most healthcare data is protected. So open healthcare data would be data that we could go onto the internet and download and use for testing our analyses or playing around with machine learning. And so this is a healthcare show, so it's nice to talk about healthcare specific data sets. We don't want to have to point you to stock exchange or sports data sets, because our package is really geared towards healthcare. So that's fun. So we thought we'd kind of talk about basically, where you could get some healthcare data, and it does exist out there. There's a good amount of it if you know where to look. So if we go to my screen, we can see, one place that's really great for imaging. There's this Grand Challenge in Biomedical Image Analysis website, and it has 80 or 90 different data sets that are imaging. Let's see, all challenges. We can click into that. Maybe it'll show us something.
How did you find this?
I found this from Googling around. So, here's one on endoscopy. Here's one on retinal scans. This one's on cataracts, coronary arteries. So, and I think there's 80 or 90 different imaging data sets. So if you want to get into some image analysis or neural nets, this is a great place to go. And then of course you have like population health type data sets. So this is the website for the CDC, and there's a whole bunch of data sets on all sorts of different population health and
so much broader than
disease metrics. And so here's one on Lyme disease, infrequently motor vehicle occupant death rates.
Whoa, that's pretty cool.
So that's kind of a fun, way to do some population health analysis. And actually, on that note, there are some blog posts on that even. And I think Levi posted some code and other data sets on population health.
Because we want the blog to be about all healthcare data, not just, health system data. So it's all fair game.
And then finally, we can look at, things like Kaggle, which is, a way to find any data set. And so if you go to Kaggle, I think, and then click data sets, you can find all of these user-contributed data sets. And so there's stuff like, FIFA player data sets and product back orders, credit card, fraud detection. But, we want to see medical data too.
Medical
is good. So like there's a great data set on diabetic retinopathy, which the Google Health Group in England used to do some pretty cool things. And then I think they published it. I think
this is actually have the images up there.
Yeah, I think that's their data set. And then
it's a nice search box.
There's another great one that's kind of interesting from the perspective of our data, which is more like electronic medical record data. Let's see, it's this one. So we get a lot of our data from electronic medical records, and this isn't exactly what an EMR might look like, but this is a pretty good data set of whether patients miss their appointments or not. And so it's pretty cool to see kind of like patient demographics and health characteristics that then relate to whether or not someone might miss an appointment.
Yeah.
I think this one is 300,000 rows.
That's a lot.
There's quite a bit of data in here to play with, and actually that's what we're going to do on this portion of the show. We're going to turn it over to Levi and let him, download and explore the data, and we can do it along with him.
Whoa. Okay, so 300,000 rows, is that big data?
Definitely getting close to big data. I like that.
Well, where's the threshold?
Close. I mean, it seems like random forest is definitely going to be fine for this data set. It might not be as good as a neural net, but I think it depends on the data.
But we can hold it. Yeah, we can hold it on our laptops, so you don't need some Hadoop cluster to hold this data and to process it.
The download's only 4 megabytes, and once you unzip it, I think it's about 25.
Okay.
So no problem holding it in memory. But Levi, I'm going to throw you under the bus, and let's get into some code.
Yeah. Okay. I think we can do this here. So I'm going to take over.
There you go.
And let us download and crunch some data. So for those of you following at home, we're going to, while the screen adjusts here, we're going to download some data, and we're going to use what Mike just described. All right.
Maybe I can talk a little bit about what's in that data set while Levi's
maybe we can talk about why is no-show data interesting? Like, what could you do with no-show data in terms of machine learning?
I like it. You're thinking about the business use case.
It's all about the business question.
That's the first step in any machine learning pipeline is like, why are we doing it? What's it going to help with?
So have we done this at Catalyst?
We actually have done this at Catalyst. We have a no-show model in production with one client right now and another one in development. And that client is using it to, what are they doing? They're either double booking slots or using extra reminder calls before appointments because missed appointments are bad for the hospital. They slow down efficiency.
Bad for business. Yeah, so either of those use cases, super helpful. So if you can see my screen here, let's focus on the screen for a moment. So we have this data set that Mike mentioned, and you can Google it easily. Kaggle medical appointment no-shows. Now, we're going to be working in R here to actually do something with this data. So let's go to R first, now that we've seen that website. So this is R Studio, and I think we've introduced this before. What we're going to do to start out is we're going to create a new project. And so R Studio is fantastic for working with data. And so in the top right, you'll notice you can click on this Project tab and then go to New Project. And what we'll do is click on, let's put it in a new directory. And the project is basically a way to group your work. So if you have some data sets, some files, you want to keep those organized, and that's what this allows you to do. So let's say, we're not going to create a package, we're going to create an empty project. And so here you would type in your directory name, and you decide where you want to put it. And I won't do that now because I actually created this, but for those of you at home doing this, go ahead and type a directory name, click Create Project, and I'll just go ahead and open a one that I created up earlier called Open Demo. And what we'll do here is we'll actually show you how to load in a data set from Kaggle. Okay, so what you do is you go ahead and look at this appointment no-show page and you click Download, and you might notice instead of just downloading it to wherever you want, you can click Save Link As and put it in the directory you just created using RStudio. And so you can find your directory there, and then you have to go and unzip it, but that's fairly easy. And so if we go back to RStudio now, what you'll notice is in that project you'll have several files. And so you'll have your rproj file, a CSV file, which represents your data. So maybe a good question for the beginners, what CSV file? You know, in grad school I hadn't really played with CSVs, did you?
CSVs?
Yeah.
That's how you get data from one place to another.
See, we used different data sets. We used like these netcdf files because we were looking at geographic data, but you use them for your medical imaging.
Yeah, it was
work.
easy, just because it was easy to write to a CSV and read from it. It's kind of a simple standard. It stands for comma separated variable, so it's a table format where a new cell is drawn just from when there's a comma, that means new cell. So it's pretty easy to create one, pretty easy to read one.
Exactly, and you have rows and tables, or rows and columns, so it's tabular data. So you'll notice mine right here, CSV, and then I have this RDemo file, which you won't have, and then you'll have an RHistory file spring up. But let's pretend that we don't have this demo file yet. We're going to create this on the fly. So for those of you at home following along, let's go ahead and create a new script. And we'll do a couple things here. First off, we need to install the tidyverse. And I've done this already, but I'll show you how you can do it at home. So install.packages tidyverse. And so you'll have to have that, and you also have to have ggplot2. And I put the little hashtag in front because the hashtag is how you put a comment into code. And the comment basically means don't run this. So
it's kind of just a note for yourself at this point?
Yeah, it's just, this code does this, so you can tell yourself later on if you forget, and that sort of thing.
Yeah, comments are really important for code because if you give your code to somebody else, they know what you were doing. So. Yeah,
and oftentimes, later, a month, 6 months later, you look at the code that you've written.
6 hours later.
6 hours, yeah. And it's like, wait, what was I thinking here? All the time. So comments are amazing. So what we're going to do is load in this data set is do D, which would represent our data frame, we'll talk about that in a minute. But basically, you do assignment by this less than and hyphen. Read CSV brings in the CSV file, and if you click tab in RStudio, it's not working for some reason. But the idea is you simply have to type the name of the file. And so we can see if we do this on the fly here. Issue, comma, 300k.csv. And this is using the tidyverse package. And so if we run this, that's a good point. So it says we cannot find that function. And so to load the function in from a particular package, you do library, and we'll load in the tidyverse. So the library basically says, okay, well, we've already downloaded this package. Now let's bring it into memory and be able to use the functions that came with it. So now if we go ahead and run it, okay, see it chugging along there. Now 300,000 rows, decent size.
Yep.
If you don't have a lot of memory on a computer, this may take a moment here, but we have it now in our memory. And so if we type D down here, look at the data set, there we go. Okay.
Cool.
So let's focus on the console for a minute. So console comes up a lot in data science, programming. What is the console, Mike?
Console is kind of that's where stuff is evaluated. It's the ad hoc place to test stuff. So if you type 2 + 2 and hit enter, it'll return 4. That's where your output comes out. So if you run a script that will print the first 5 rows of that data we just loaded, it'll come up in the console.
Yeah, so basically how you interact with the program a lot of the time. And so we see in the console here, we have this data set, and we have our columns, age, gender, appointment registration, time and date, day of the week. stuff that relates to no-shows. Awesome, just what we expected.
Yep.
And you notice this is a tibble. So the tidyverse uses what are called tibbles, which is a nice tidy way of looking at data. You might have heard of data frames, so it's something similar to that, just a little more tidy. And so you'll notice we have 300,000 rows, 15 columns, and not all the columns are shown here. You'll notice down below, and this is one of the beautiful things of tibbles, is that you have all the different columns listed that weren't shown here. So, okay, well, we brought our data in, and for some people that'd be really cool, but some people are like, okay, well, loaded data in, great. So I guess where would you start with, you bring in a data set, like what are the first things you do with data when you start to look at it?
Oh, the first thing I do is I want to know what's in it, so I would just get the column names.
Okay.
So you could do something like names of D and get the column names, get all of them.
Okay.
Does the tibble there show
Yeah,
you all
yeah.
the
So
column
we haven't
names,
talked
or-
about tibble much, Mike and I, but here's the tibble. So
Oh,
actually,
so it does show you them
yeah,
all.
it's
Man, that's
quite
so
nice.
helpful.
And the tibble, above and beyond the data frame, so the tibble actually shows the type of column you're looking
that's
at.
great.
Yeah.
So
So
it
the
tells you
tibbles-
what's what.
Tibbles are pretty fantastic. And so let's actually do something with this, right? So ggplot, we loaded that in. Well, we installed it, and we're going to load it in now because ggplot is how we like to plot. And you can plot with base R.
Yeah. ggplot looks a lot nicer, though.
It can look nice, yeah, in a
Looks
lot of
really
cases.
nice. And it does a lot of really handy things for you.
It's super handy. Okay, so we loaded in our functionality from ggplot, and let's go ahead and do something here. So I am lazy, and I like to Google stuff, so let's just pretend we don't have this page up, and let's say, ggplot, give me a histogram. Done. Okay, so it's the top link, click through, just for reproducibility, so you can all do this at home. Now, with documentation, you often have, arguments, things like that, but a lot of times it's easiest and most exciting to just skip to the example, which is what we're going to do. So let's skip down to the example and grab the first couple of lines here. We'll adapt it to our use case, and we'll start with a histogram. So a lot of times you want to look at a distribution. You want to see, like, okay, well, how does my data look?
That's part of this exploration process, right? Once you
Yeah.
want to know what's in the data, graphing it is a great way to do that. So
Yeah, so before you do machine learning, it's best to kind of see, oh, well, what data do I have? So we'll copy this, drop it into our studio, and we'll change a couple things. So the first element here that I highlighted is the name of the data set, so that's now D. And we have to choose a column to look at. So the ggplot syntax is fairly simple. So you'll be working in this AES object a lot of the time, or working with whatever you call the AES indicator here. And so this is where you say, okay, well, what is the column that we're going to be looking at on the X or Y axis? Histogram is nice because you only have to specify one. But let's look at age real quick. And so we just go ahead and put age in there and run these two lines. Notice we don't have to load in the data set again. Already in memory, so we can click run.
with those lines highlighted, though, right?
Yeah, highlighting the two lines of interest. There we go. So we get some sort of warning there. I don't know if we necessarily have to worry about that. But to get to the punchline, we have our histogram here, and it's fairly basic since it's just very minimal code. But the idea is you have an example of, okay, well, most of the folks in this data set, they're, 50, 60 years of age. And
That kind of makes
pretty
sense,
steep drop off, yeah.
'Cause you're probably going to have, more people of that age coming to the hospital than anywhere else.
Yeah, it's interesting that it's not like normally distributed. So notice how fast it drops off for folks over 60. Maybe there's a different Medicare clinic or something that the older folks use. But there we go, an example of how to start looking at data once you've downloaded it from Kaggle, using modern tools that are free and easily set up. Download it from the internet and get going using what we showed here. So, Mike, any questions, any comments?
So now what would be the next step if you were to use ggplot?
Yeah, so that's a great question.
I guess maybe I'd want to look at maybe how the age is associated with each gender or something like that.
Yeah, so we could start with some box plots, that sort of thing. So there's a lot of great documentation on ggplot. So if we go ggplot, box plot, if you're familiar with box plots, or if you're not, they're fantastic, and you can see all the documentation here that you can easily grab. So if we scroll down to the example code, you can easily see, okay, well, wow, 2 lines of code there gets me that nice box plot. and you can kind of take it from there and Google around for other ggplot things that you want to do. So scatter plots,
Yep.
and filling in lines, or just cumulative distributions are cool. But that's the demo for today. Anything that we need to go over? Any housekeeping items or anything? We want to keep these tight.
Yeah, we had a couple of questions through the chat we could touch on real quick. Someone asked why that we thought Netflix maybe switched from a thumbs up, thumbs down to a star rating system, and I didn't know that happened, but I gave my best that maybe it's more gradation within the star system, so you get a more accurate representation, or maybe it's just more familiar to users.
Yeah.
And then we had some people asking about we had someone ask about what we spend our days doing, but I think we're going to have to save that for a future topic because it's just too many things to think about.
A lot of stuff, yeah. Model building, package work, lots of good stuff. Education. In terms of Netflix, though, they've actually recently switched even from stars to an actual percentage as to how much you'll like this movie.
Did they really?
Yeah, so it's super precise now.
Well, that's the feedback they give, right?
Yeah. So the ratings, I think, would be stars. I haven't checked. Anyhow, great questions. Cool. Join our Slack channel. Join the healthcare AI community at healthcare.ai. And you can sign up for the emails that will send out our blog posts. Check us out. Subscribe, like, and share. Thanks for joining. We'll talk to you all next week.
Thanks, everybody.